Hands up, anyone running legacy workloads? Anyone? Awesome. Well, keep your hands up if you're running .NET workloads. There's quite a few of you. Well, congratulations, you've come to the right session. Now, I know you've experienced some pain in dealing with your .NET workloads. And let me guess, does it break often? What if I told you you can take your .NET apps on an adventure, just like Mod, the .NET bot here? Hello, my name is Maini Titani. I'm a solutions architect from AWS, and I love containers and modern applications. And today I'll show you how you can actually run your .NET workloads on Linux containers on AWS. And Mike, who is our senior solutions architect from AWS, will guide you through some of the developer toolings that are open source and AWS driven to help you modernize your application code. And I want you all to come along with us and Mod the .NET bot as he leaves the monolithic world behind and embarks on a modernization journey to platforms he's never seen before on AWS. And best of all, you get to choose your very own .NET adventure with the .NET Adventure game, but more on that later. And best of all, it'll be a whole lot of fun without a whole lot of pain. So .NET, previously called .NET Core, is the core cross-platform successor from the .NET framework. Now, you may have already considered modernizing your .NET framework apps to .NET, but I just wanted to dive into why this is important for you. And here are some of the 6 top areas that our customers told us why they chose to modernize to .NET. And the first area is performance improvements. Now, .NET is a redesigned version of the original .NET framework, and it has a modular architecture with a set of simplified core libraries. Now, it's built on a high-performance runtime that's designed to handle server and cloud workloads at scale. So if you're trying to improve your performance, then going to .NET is your first point of call. Cross-platform. Now, another great reason to migrate to .NET is that now you can run it on Mac OS and Linux. And it opens you up to a wide range of possibilities, like running it on a Raspberry Pi. Lower your total cost of ownership. Now, .NET supports x64 and ARM-based workloads. So that means you can use AWS Graviton. Now, Graviton processors are custom built by AWS to deliver the best price performance. So running .NET on AWS Graviton gives you a 40% better price performance in comparison to EC2 instances. Go open source. So .NET is free and it's open source according to the stewardship of the .NET Foundation. So this means that being open source, anyone can contribute to its development. The .NET ecosystem is innovative, it's commercially friendly, and it has continuous community updates. Simplify your package management. Now, the .NET framework is serviced using Windows updates, whereas .NET is modular based on the package manager NuGet. Now, NuGet simplifies the packages that are managed within your project. And last but not least, .NET is the future of development. New applications should be built using .NET instead of the .NET framework, and .NET 6.0 is the latest long-term support release. So what are the options that you can take in order to modernize your .NET workloads? Now, there are 3 destinations. You can re-platform with containers or refactor with AWS Lambda. So let's dive into each of these options. So the first destination is to re-platform and containerize applications with serverless containers. Now, I know what you're thinking. Did I just hear the word serverless containers? And I know you're used to being in either team serverless or team containers. Well, what if you can abstract the EC2 instances away with Amazon ECS on Fargate? Amazon Elastic Container Service, or ECS, is a fully managed container orchestration service that helps you easily deploy, manage, and scale containerized applications. Now, it's a fully managed service, and it comes with AWS best practices that are built in. Now, AWS Fargate is a compute option that you can use alongside ECS, and it helps you scale containers without having to run EC2 instances. And today, I'll be showing you a demo where you can make changes to your .NET web application running on Linux containers on ECS on Fargate via a blue-green deployment strategy. So destination number 2, what if you're brand new to containers, but you're curious about getting started quickly? Have a look at AWS App Runner. Now, AWS App Runner is the easiest way to run your web applications on AWS, as you don't need to have any orchestration or infrastructure scaling. So it can go from an existing container image or source code repository or an existing CI/CD workflow to a fully running containerized application on AWS in minutes. And best of all, App Runner was launched in the Sydney region just last month. The third destination is to refactor your application code so you can run it on AWS Lambda with a container image. Now, Lambda is a serverless event-driven compute service that you can run code for virtually any type of application without having to run or manage servers. Now it has container image support for Lambda functions, so you can have 10 gigabytes of storage for your application and use familiar container development tools. So look out for Mike's upcoming demo where he uses developer tools to deploy a .NET workload on AWS Lambda using a container image as well. Well, you might be asking yourself, I'm still not sure which of the 3 options I should take. Well, do I have a quest for all of you here? What if there was a fun, interactive way for you to find out your .NET destiny to play this game? Well, what you do when you play the game, slay the dragons, get the secret codes, and come and visit the AWS She Builds or Modernize on AWS booths. You can't miss it. There's a huge AWS logo on the ceiling with the secret codes and get some swag. Now, this swag is limited, so it's first in, first served for those that slay the dragons. So let's take a look at the adventures of .NET Game. The intent is to slay the dragons who stole the town's code from Mod the .NET bot. Now, the game is designed to help you decide on which of the 3 destinations you should choose for your .NET workloads. Is it ECS on Fargate? Is it App Runner? Or is it Lambda with containers? Walk around a familiar land and encounter familiar enemies like worked in non-prod crab. So, are you keen to start to play the game? Well, you're going to have to wait until the end of the session to actually get the QR code to run this game on your mobile or laptop web browser. So not only can you have fun playing the game to find out where your .NET workloads land on AWS, we'll also help you with a solution to get you started to run your .NET workload through a CI/CD pipeline that allows for blue-green deployments. Now, a blue-green deployment is a deployment strategy in which you have 2 separate but similar environments. One environment, blue, is running the existing application, and the other environment, green, is running the new application. So why use a blue-green deployment strategy? It increases application availability and reduces development risk by simplifying the rollback process if a deployment fails. Now, once testing has been completed in the green environment, the traffic is switched over to the green environment and the blue environment is deprecated. In the upcoming demo, we'll start off with 4 tasks within our ECS cluster. 2 from the existing blue environment and 2 from the new green environment. As we start to shift the traffic over to the green environment, we'll end up with 2 tasks in total. So let's have a look at how our demo progresses with the architecture diagram. As part of the DevOps team, I authenticate via AWS IAM, or Identity and Access Management. In the first source stage of our CI/CD pipeline managed by AWS Code Pipeline, I push changes to my source code repository, which is AWS Code Commit. In the second build stage of the pipeline, Code Build starts building the .NET 6.0 container image. Now, Amazon S3 is also used for storing any artifacts that we need during this build phase. The container image that we built during the build phase will be pushed out to Amazon ECR, or Elastic Container Registry, which is where we store our container image. Now, the new container image is then pushed out to our ECS cluster from ECR, which reflects the changes on our web application in the green environment. Now, let's take a look at our container cluster on ECS. From the networking perspective, our cluster operates on 2 availability zones for high availability. Now, there is a public subnet for communication to the internet via the NAT gateway. We do have an application load balancer that directs traffic to the ECS service, and a service is used to guarantee that a set number of tasks is always running, in this case 2. Now, in the final deploy phase, Code Pipeline will create an additional 2 tasks for the green environment, 1 in each availability zone. So let's take a look at our web application running on Linux containers on ECS. This is a .NET application, and I'm going to make changes to this via blue-green deployment strategy. Now, we have a white background, and I'm going to change the background color and change the messaging as well. And we're going to use Visual Studio Code, which is our IDE. Now, remember, we talked about having a total of 4 tasks, and we're going to that's going to come down to 2 tasks as we switch from blue to green. So let's take a look at our IDE, which is Visual Studio Code, and I'm going to be updating the background color to light green. Now, why light green? It's because we want a visual indicator that we're going from blue to green. And I'm going to update the messaging as well to welcome to AWS ANZ Summit 2023. I'm going to save that file, and then I'm going to go over to Git and then create a new branch called demo v3. And I'm going to add that file that I just made a change to, and then I'm going to commit that file, and then I'm going to push those changes to the main branch. Now, as I'm doing that, in the next page, I'm going to the AWS console and check out how my pipeline is doing. All right, we're in the AWS console, we're in Code Pipeline. So I want to see if my pipeline is kicked off. And great, it's already in progress. Let's take a look. So we're in the first stage, it's already successful. Now, I want to make sure that my Git push has been reflected to my source code. And I'm going to go into AWS code commit. You don't have to use code commit. You can use whatever source code repo that you're comfortable with. So let's take a look. We're looking for green to indicate success. Great, we see a sea of green, which is awesome. The red indicates the previous message that was there. I'm happy with that. So let's go back to Code Pipeline to see where we're at in terms of the status. So I believe we've progressed to the next stage, which is the build phase. So code build is starting to build out our container image. And we have initially logged into ECR, or Elastic Container Registry, which is where we're pushing the container image to. And as you can see all the build logs there. We've logged into ECR, and we're starting to pull down the .NET 6.0 container image and building this out layer by layer. And we're pulling in any external or S3 sources as well as we start to build out any dependencies for our container image. Great. We've finished the build phase. We're off to the last stage, which is the deploy phase. This is where we take a look at our ECS on Fargate container cluster. So let's have a look. Remember, we talked about having a total of 4 tasks, as you can see. So we are trying to see, we have 1 in the existing blue environment, 1 in the green environment. So we've got 2 in both. And as we start to deregister some of the tasks in the blue environment, we will see that in the log message below. And we're trying to get that to a total of 2 tasks as we switch over to the green environment. Great. So we're starting to deregister these tasks and also drain the connectivity in terms of our tasks existing in our blue environment. Excellent. Let's go back to our tasks and give it a refresh. We've come from 4 tasks now down to 3 tasks. Fantastic. It's in progress. So as we come down in terms of our task count to a total of 2, let's check out our cluster health. So the great thing about ECS is that you have observability and monitoring metrics such as CPU and memory utilization without having to install these monitoring tooling additionally. And you can add these metrics to your CloudWatch dashboard. And it's pretty handy to keep your container cluster in check as well. So let's go back to our deployments, and we're starting to drain the last of our tasks. So it'll be any second now as we switch over to the green environment. So let's go back to code pipeline to see where we're at. Any second now, look out for the green. And there you have it. We have succeeded, but I want to make sure that we've really switched over to the green environment. So let's take a look at our ECS service. Remember, our tasks talk to the service, our service talks to the load balancer. So as we dive into the service, let's take a look at our load balancer URL. So as we click the load balancer URL, what we're looking for is the web application with a light green background. And there you have it. We have successfully deployed a new version in our web application and switched over to the green environment. Achievement unlocked. So you found your .NET destiny as you walked alongside us and Mod the .NET bot to take a look at the platform view. You saw how you can deploy changes to your .NET workload via Linux container with ECS on Fargate with blue-green deployments. Now, what tools do you think Mod will need in order to unlock their application code? Now, as a developer, where do you start? How do you build, port, or migrate your .NET apps to AWS? Mike will guide you through the developer tooling that's used to modernize your .NET workloads.
Thanks, Mike. Awesome. Great to see everyone here at AWS ANZ Summit 2023. Raise your hand if you're excited to learn more about modernization of .NET applications on AWS. Awesome. My name is Mike. I'm a Senior Solutions Architect here at AWS, and as Mike mentioned, I'm going to be looking at .NET modernization from a developer's perspective. As a .NET developer, you prefer to work in familiar environments such as Visual Studio or Visual Studio Code, and you want your tools to seamlessly integrate into your workflow. The AWS Toolkit is a plugin that extends your preferred development environment, providing rich integration with AWS services. There are AWS Toolkit plugins and extensions for the most common development environments, including Visual Studio Code, and JetBrains Writer. And you also want easy access to AWS SDKs and APIs to quickly integrate AWS services into your applications. The AWS SDK and APIs include libraries that provide consistent and easy-to-use interfaces for working with AWS services. This includes templates for creating AWS projects in Visual Studio so that you can get up and running quickly. And we all know how important CI/CD, or continuous integration, continuous deployment, is within the software development process. It's the automation of processes to build, test, and deploy software with the overall goal of improving quality and the speed of software delivery. In the previous architecture, Maya had mentioned and demonstrated the AWS Code Pipeline and AWS Code Build. These are common services that our customers use to build and deploy .NET applications. But I also often talk with customers who are using Azure DevOps. The AWS Toolkit for Azure DevOps is an extension that easily integrates AWS services and processes into your existing pipelines. And lastly, cross-platform development is becoming increasingly more important as developers embrace different platforms, different developer environments, and different deployment targets. Being able to develop cross-platform gives .NET developers more choice. It opens up performance, efficiency, and even cost advantages. In this demo, I'm going to show you how easy it is to get started with building .NET applications on AWS. I'll create a sample containerized application, deploy it to AWS Lambda, and interact with some common AWS services, all from the comfort of my preferred Visual Studio development environment. So this should look familiar. This is our Visual Studio development environment, and I've already installed the toolkit for Visual Studio. Firstly, I'll go ahead and create a new project. The AWS Toolkit comes with many templates included to help get started quickly. For this demonstration, I'm going to use the AWS serverless application using C# and click Create, or click Next. I'm going to give my project a name. and then click Create. Next, I'm asked to choose a blueprint. A blueprint is a boilerplate project that creates a great starting point for your application. There are many blueprints to choose from, but for this demonstration, I'm going to choose the ASP.NET Core 6 Container Image Blueprint for Lambda. Because I'm using the Lambda Container Image Deployment model, you can see in my solution, my project directory, that I have a Docker file. This is a standard Docker file that you'll see anywhere. Next, I'm going to open up the startup.cs file, which initializes our ASP.NET application and related services. I'm going to make a simple modification for AWS ANZ Summit. I'll save my file, and I'll run this on my local machine just to make sure that I'm happy with my change. Awesome, that looks great. Next, I want to be able to deploy this to my AWS environment. So to do that, I'm going to right-click on my project, and I'm going to choose Publish to AWS Lambda. I'm then presented with a wizard to help guide me through the process. I'm going to provide a stack name, and I'm going to create an Amazon S3 bucket directly from within the wizard. And go OK, and publish. This will take a couple of moments while my Visual Studio builds my application and creates a Docker image, builds a Docker image. Once my Docker image is built, it is then pushed to AWS Elastic Container Registry. And then AWS CloudFormation starts to deploy my application and associated services to my AWS account. Once that's been completed, I'm then shown a AWS serverless URL, which I can then click on to view my application running in the cloud. Awesome. Next, I'm going to show you the AWS Explorer component of the AWS Toolkit. The AWS Explorer includes multiple services that you can easily interact with in your AWS, your preferred IDE. I've generated some logs now since I've visited my application, so I'm going to open up the Amazon CloudWatch, go to Log Groups, refresh my logs, and open the latest log stream. And I can easily get access to the logs that my application has generated. This is really useful for debugging purposes. I'm going to go back to my AWS Explorer, and you can see that there are many AWS services that I can interact with directly from my Visual Studio development environment, including uploading and downloading files from S3, looking at Lambda functions, editing CloudFormation templates. So you might be thinking, look, Mike, I've got this .NET application. It's built on the .NET framework. Where do I begin to modernize? How can we leverage the latest .NET release if we're built using the .NET framework on Windows and we're using Windows-specific libraries? Well, AWS has a few tools here to help. The first one is the AWS App to Container. This is a command line tool to help modernize .NET and Java applications into containerized applications. App to Container analyzes and builds an inventory of all of your applications running in virtual machines, on premises, or in the cloud. You simply select the application that you wish to containerize. App to Container packages the application artifact, identified dependencies into container images, and then generates ECS task definitions and Kubernetes pod definitions for use in your preferred container orchestration platform. Then there's a porting assistant for .NET, which is an analysis tool that scans your .NET framework application and generates a .NET Core compatibility assessment, helping you port your applications to .NET faster. And then there's the AWS Microservice Extractor for .NET. This is a tool that automates the extraction of microservices from .NET MVC monolithic applications. It does this by scanning the application, it builds a dependency graph, and carves out API interfaces into separate projects, ultimately making it easier for your teams to get started with microservices. So let's see how Mod, the .NET bot, can use these tools to help him along the journey. Has anyone seen Mod, the .NET bot? Mod, the .NET bot, was preparing for a new mission, tasked with modernizing an outdated .NET application. Mod was excited to take on the challenge. The first part of the journey was to re-platform using containers. The containers provided increased agility, portability, and scalability. Mai showed us how easy it was to build with containers on AWS using a blue-green deployment model. Mod was amazed at how quickly the application could be deployed and scaled up and scaled down to meet demand. It was a huge step forward in modernizing the application, bringing it up to speed with the latest technologies. The second part of the journey was to refactor the application. Mod was familiar with Visual Studio, but wasn't sure how to get started with modernizing on AWS. I demonstrated the AWS Toolkit, which showed how easy it was to use AWS tools and services right from your preferred development environment. In that same demo, I deployed a new .NET application directly to AWS Lambda. I then spoke about some of the tools that you can use for .NET modernization. Mod evaluated the application using the porting assistant for .NET so that they could take advantage of the latest features and benefits of .NET. Mod also realized that the application was a large monolithic structure, and it was difficult to maintain and update, especially with their other robot friends. Mod started to break down the monolith into smaller, more manageable pieces using the microservices extractor. Each piece was designed to work independently using containers or serverless technology. The new application was more flexible, more scalable, and easier to maintain than ever before. The application was now modernized and ready to take on the future. The journey seemed difficult at first, but in the end, it was well worth the effort. And with that, Mod was ready to take on the next modernization challenge that came along, helping to bring old .NET workloads into the cloud, one app at a time. Today, you all learned about the solutions and the tools to help modernize your .NET workload on AWS. So how do you get started with building with the solutions and the tools that we spoke about today? And where do you go to find and play the .NET adventure game to find your .NET destiny? Well, you can actually find that here at this QR code. So if you want to start working on your .NET app to a new destination in AWS, make sure to scan this QR code. You can play the .NET adventure game to find your .NET destiny. And if you're here with us today at Summit, please visit the Modernize on AWS and AWS She Builds booths to collect your exclusive swag. But make sure you slay all of the dragons and find the special code for Mod the .NET bot. You can also build your own .NET CI/CD solution on ECS on Fargate and discover more .NET-related resources and developer tools from this same link. Visit the AWS Skill Builder to learn more about modern applications and .NET on AWS. Thank you for joining us, and don't forget to please complete the survey and keep modernizing on containers and serverless.